Hi everyone, today we're going to talk about setting up open loop boost control and boost bar gear. First of all, what you need. We highly recommend using a 3-port Mac valve like this one to control the boost. These are widely available and we also keep them in stock. If you're using an external wastegate actuator with a single port, it needs to be connected like this, with the compressor exit before the throttle body connected to port 3 and port 2 connected to the wastegate actuator. This way, when the valve is off, the actuator sees the boost pressure, and the boost pressure is set by the spring in the actuator. When the valve is on, the actuator sees atmospheric pressure, and the spring holds the wastegate shut. If you're using a dual port actuator, it needs to be connected like this, with the compressor exit connected to both the underside of the diaphragm and port 1 on the valve. Port 2 on the valve connects to the top side of the diaphragm. This means that when the valve is off, the top side of the diaphragm sees atmospheric pressure, while the bottom side sees boost pressure, giving you the boost set by the actuator spring. When the valve is on, both sides of the diaphragm see boost pressure and the spring holds the wastegate shut. Next, you need to connect one side of the Mac valve to an aux output on your ECU. If it's a 420C or a Select, you need to use auxiliary output 1, 2 or 3 because those are pulse width modulation capable. The other side of the Mac valve then needs to connect to ignition switched plus 12 volts. You then need to configure that output as a wastegate control, enable PWM and select 25 Hz as the PWM frequency. Next, on the wastegate screen, you need to select the maximum duty cycle as 100%, the minimum throttle and map that the ECU will need to see before it activates the valve. Below this, the output from the ECU will be switched off. This saves wear on the valve as well as reducing noise when you only need the wastegate boost pressure. Then, on the wastegate screen, you can select the duty cycle of the valve that you want at each RPM to get the boost curve that you want. In practice, this is normally done via trial and error, but a good place to start is this formula. Now, this car that we're testing it on is Becky, which is the Turbo Mazda 121. Being front-wheel drive, we really need to run boost bar gear. Step 1 in this situation is to add speed sensors to the car. If you already have a good Hall effect sensor on the gearbox output, you can just connect this into the ECU Master Vehicle Speed Sensor Input, MVSS. This car doesn't have a good sensor, so instead we need to run a speed sensor on each front wheel and use the 440 ECU because the 420D only has one VSS input. The best sensors we find are the Honeywell GT101 sensor, and we keep these in stock. On this car there are holes in the brake backing plate that line up with the wheel studs, so the sensor can be triggered by the wheel studs as the wheel rotates. Being Hall effect, they work in a steady state, which means that when the sensor is facing the back of the stud, the output is low, and when the sensor is not facing the stud, the output is high. After mounting the sensor and wiring it up, you should check that it works by rotating the wheel by hand, and that the MVSS input triggers correctly when you look at the diagnostic window, which you get by hitting F11. The sensors need a supply, which can either be 5 volts or 12 volts, a signal ground, and they give a digital output to the ECU. So because it's a Hall effect, the ECU needs to be set to digital mode and the inputs need to be enabled in the software. Once you've confirmed that the sensors are working, you can calibrate them by driving at 50 km an hour and clicking the Learn buttons. This is best done with a passenger assistant or on a dyno for obvious reasons. Having done that, you should now have a correct MVSS reading on your gauge window. You can then drive in each gear and click the Learn button for each gear so that the ECU can learn the ratio between the road speed and the engine speed in each gear. You will also need to set a tolerance value for how close these need to be. We find that values around 120, which corresponds to a 12% difference between the measured speed and the theoretical speed, work fairly well unless it's an ultra close ratio gearbox. From then you can select in the F11, you can check in the F11 window that the ECU is detecting the current gear correctly. Having done all that, all you need to do to engage boost bar gear in open loop boost mode is put in the wastegate duty cycle that you want the ECU to limit to when you're in each gear. Again, you can determine this experimentally, but the formula that we gave earlier should be a good starting point. And there you have it, boost bar gear with just a Mac valve and a speed sensor.